So good morning, everybody. Welcome and thanks for joining this webinar on the UK modelling contribution to CMIP7. So first, I'd just like to say a big thank you to UK NCSP, the National Climate Science Partnership, for helping to organise this. And if you're new to UK NCSP, Mike's going to introduce it briefly in a minute. But I'd like to say particular thanks to Wendy and Rose for helping pull together the newsletter that you may have seen and also organise this webinar. Also thanks to Jane, who's done an awful lot of the prep for this, and all our speakers this morning. I won't waste time reading the agenda, but basically this webinar is a first step. So maybe we go to the next slide, please. Who's controlling the slides? Perfect. Yes, so this webinar really is the first step to providing a bit more engagement and communication on how we're preparing for CMIP7, particular focus on the fast track, and we'll hear about that in a minute. So UK NCSP is a really good new mechanism we can use to facilitate this in partnership between the Met Office and the NERC community. We're also very lucky to have Helene Hewitt online, who's the UK lead for CMIP. Well, she's the co-chair of CMIP now, and that's a really nice opportunity for the UK to be particularly influential in CMIP7. So it's important that we make a good contribution. So we'll be talking a little bit about our plans, current model configurations, the timeline, the technical details and data delivery, and then we'll cover a little bit links to the longer term plans beyond the fast track, and particularly how then that engages with the wider community and the MIPs there. So the next slide, I think, is the agenda. Hopefully you will have seen that. I won't waste time by reading through it. And then the next slide, please, is a little bit of housekeeping. So the main thing is, as you will see in the chat, please keep muted unless you're asking questions at the end. This call is being recorded. We will make the recording available and share the slides afterwards. When we get to the Q&A, please use the Q&A function in Google Meet. So this slide hopefully shows you how to do that. It is separate from the chat. So if you have any technical difficulties, then you can use the chat to ask for help. But otherwise, please use the Q&A. So use the little 9-dot symbol for meeting tools, and then there's a Q&A session on there, and that will allow you to both write in a question, but also you can upvote questions, and we'll go through those at the end. So without further ado, I'm going to try to chair this and keep us to time according to the agenda. We've just got a couple of short introduction talks, and then we'll go into the details of different model configurations. So first up, I think we've got Mike Meredith, who will be introducing the UK NCSP. So over to you, Mike.
Okay, thanks, Chris. I hope everyone can hear me. As Chris mentioned, this is just a very short introduction to UK NCSP for anyone who has not come across it before. I hope that most of you have, but there may be some that haven't. Can we have the next slide, please? UK NCSP is a relatively new initiative, and it spans all these institutes listed across the bottom of the screen. So it's essentially the Met Office and the NERC-funded research institutes. The idea behind UK NCSP is to better address climate change. The idea there is, of course, that climate change is one of the leading order challenges facing humanity, and the scale of the response needs to match the scale of the challenge. And that includes the scale of the scientific response, so how we develop our understanding of climate change so that we can take the right actions to deal with it. The long-term goal is to produce better scientific evidence to feed through to policymakers, decision makers, people who can actually influence the trajectory of society in the UK, society generally, so that we're better prepared for climate change and what it has to bring. Why these particular institutes? The reason is that between them, they actually are responsible for quite a lot of the UK's large-scale, long-term climate science capability. And by that, I mean things like research aircraft, research planes, research stations, large supercomputer facilities, the ability to create and run models for decades and centuries. And it's this sort of large-scale, long-term remit that is the unifying feature across many of these laboratories. Of course, it doesn't exist in isolation. There's a whole broader research community out there, nationally and internationally. And of course, we do also need to connect to industry, to government, to policy domains internationally, and so on. But by doing that, we can hopefully make better and optimized use of the science capability that we have. Next slide, please, Wendy. To begin with, we've started with 4 working groups. You'll hear more about these over the coming weeks and months. One is on provision of climate observations, and that group is actually having a webinar later this month. So if you'd like to sign up for that, there's a QR code here. If you're not quick enough with your phones to scan that, you can of course play the recording back later and scan it from the recording, or just email us and we can send you details. There's another group being formed on climate modelling, which is very specific, very germane to today. This includes responsibility for things like CMIP7 in the UK. There's a group on climate interventions, and there's a group on sea level rise have been formed, and these are beginning to coalesce and conduct the activities to ultimately influence the policy domain. Next slide, please. Those are just the ones we've started with. It's going to expand over time. We've already got quite a few emerging and embryonic activities that we're beginning to spin up. One of those relates to options for new UK climate reanalysis, including data rescue exercises to extend its temporal domain. There are other ones in there as well about how we make optimal use collectively of artificial intelligence and machine learning in climate science. And you'll hear more about these in the coming months as these are developed and put into action. Next slide, please. We're relatively new, but the next steps, we're seeking to scale up our stakeholder engagement. We've already started a dialogue with some government departments and we're scaling that up. There's other conversations spinning up around that. We also want to scale up engagement with industry, devolved administrations, and so on. But also we need to connect across nationally and internationally in the academic sense, both in the climate science sense, but also other domains such as social science, economics, health science, and so on, all of which are relevant to climate and how we deal with climate and its impacts. And we also need to engage internationally, especially with organizations like UNFCCC, IPCC, and so on. And again, today's webinar on CMIP is very relevant to that because of its importance to IPCC. Next slide, please. And just to flag, the UK NCSP Programme Office is now populated. These are the mugshots of the usual suspects. There's myself and Matt Palmer acting as joint directors, and there's Rose and Wendy, who are respectively the knowledge integration lead and program manager. We'd love to hear from you. We'd love your engagement. There's a QR code here that you can scan just to sign up to be regularly communicated by us, or if you're an old Luddite like me, please just drop us an email and we'd love to have your participation and engagement. And that's it from me. I'll hand you back to Chris and say thank you very much.
Brilliant. Thanks so much, Mike. Yeah, and thanks to all the team. It's really nice that we can use this as a way to kickstart UK NCSP as well, I think. So yeah, I didn't say we're not going to take questions as we go, but by all means type in a question if you have any for Mike, and we'll come to them at the end. But now I'm going to hand over to Helene, who's going to tell us a little bit about CMIP7 and particularly the fast track.
Thanks, Chris, and I'm Helene Hewitt. Although I work for the Met Office, I'm presenting this as the co-chair of CMIP, which, as many people will know, is part of the World Climate Research Programme, We're really lucky now that CMIP is supported by an international project office funded by the European Space Agency, and that has allowed wide engagement across the community to develop CMIP7. So many thanks to everyone listening for their past and ongoing contributions. So next slide, please. So as many are aware, following extensive consultation after CMIP6, the CMIP panel decided to evolve the design of CMIP towards fast-track sets of experiments, supporting particular applications, and allowing other model intercomparison projects to run on their own timelines. The first fast track will be the assessment fast track, which is aimed at delivering key experiments for IPCC, AR7, and other national climate assessments. The DEC continues to provide model benchmarking through idealized experiments and historical simulations. CMIP has been working towards more regular updates of the historical climate forcings. They were last updated for CMIP6 and ended in 2014. An update of all the historical forcings to 2021 is now virtually complete. Next slide, please. So during the fast track development, key science questions for CMIP7 emerged. You can read more about these in the Dunn et al. CMIP7 paper in Geoscientific Model Development. Briefly though, they cover patterns of sea surface change, changing weather patterns, the water carbon climate nexus, and tipping points. And many of the fast track experiments and other planned model intercomparison projects map onto these questions. Next slide, please. So I won't go into the details, but this is the summary of the assessment fast track. You can read more about it in the paper or look at the QR code. Broadly, the experiments are divided into two groups, one covering prediction and projection, both decadal predictions and future scenarios. And the other group of experiments covers process understanding, including both attribution and characterization to support understanding of the predictions and projections. Next slide, please. The details of the scenarios chosen for CMIP7 is documented in the Van Vuuren paper, also in GMD. You can see here the 6 scenarios. The highest is intended to be closer to SSP 3.7.0 rather than SSP 5.8.5 in CMIP6, and the low end includes 2 overshoots. One of the flagships for CMIP7 is that the projections will be emissions rather than concentration driven. And we expect that this may increase the spread in the future projections due to uncertainty in the carbon cycle. The main scenarios will run to 2100, with extensions to 2150 and beyond to 2500 possible. Next slide, please. So I won't go into the details, but this is the timeline for the production of the assessment fast track. It's involved a lot of underpinning activity, as well as model development, which you'll hear about the UK contribution shortly. This includes selection of experiments, development of the historical forcings and the scenarios, development of the data request, and work on the Earth System Grid Federation, or ESGF, and underpinning infrastructure to allow the data sharing. We've been developing a rapid evaluation framework, which will provide access to standard metrics when data is uploaded onto ESGF. The CMIP panel is asking the climate modelling community to have the assessment fast track data delivered by January 2027, which we believe should be in time for the AR7 assessment. Work is also underway with the Cordex, CMIP, and ISMIP communities to make data provision to these downstream activities run smoothly. I'll just draw your attention to the CMIP community workshop, which will take place in Kyoto in Japan next March. We are currently looking at a lot of session proposals for that workshop, and I'm sure it will provide many early insights into CMIP7 results, particularly for IPCC. Next slide, please. So finally, please don't hesitate to sign up for the CMIP mailing lists and the CMIP seminar series. Recordings of these are on the website. And I leave you with a few useful links. There's 2 special issues in GMD on CMIP7 and the forcings. And please look at the CMIP website for more information on forcings, data request, and rapid evaluation framework. So thank you very much for your time.
Brilliant. Thanks, Helene. And thanks so much for everything CMIP and the IPO are doing. I think they've been really engaging with the community, which is great to see. Okay, so we rapidly move on. The next 3 talks are going to describe to us the current configurations we're planning to run in the UK, contributing towards CMIP7. So we're going to start off UKSM and Colin, and just a reminder, you've got 10 minutes and I'll give you a quick reminder after 9. So over to you, Colin.
Can you hear me okay?
Yes, perfect.
Right. Okay, thanks, Chris, and thanks for everyone for joining. Okay, so I'm going to tell you a little about UKSM contributions to CMIP7. I'm going to have to start with, next slide, please. I'm trying to change them myself. One piece of negative news to start with. So just as a reminder, the UKSM team per se has significantly less resource available to us than we did for CMIP6. So please bear that in mind as we try and realize CMIP7 and the fast track. Next slide, please. Okay, so the CMIP7 assessment fast track. So we've set a timeline for ourselves. This is the UKSM contribution of the experiments I'm going to explain in a minute that we will try and do centrally, of a 12-month calendar period, essentially, from July of this year to July of 2026, where July of 2026, we will aim to have the data that we have simulated as part of the fast track available on the UK ESTF node at CEDA. So that's our operating timeline. It's obviously contingent on forcing availability, which we don't have a direct control of, but our understanding at the moment is this timeline would fit with when the forcing data for both the historical and the SINAR MIP runs will be available. Next slide, please. Okay, so in the CMIP7 assessment fast track, so independent of the science MIPs now, so the assessment fast track, we're going to use a model configuration referred to as UKSM 1.3. And I'll explain a little bit what that is now in the next couple of slides. So next slide, please. Okay, so for CMIP6, we used UKSM 1.0, which is documented in Alistair Sellers' paper of 2019 in James. That model was further developed over the subsequent couple of years to something called UKSM 1.1, which is documented in Jane Mulcahy's paper in GMD in 2023. In particular, that addressed some aspects to do with excessive aerosol forcing and a cold bias mid-century that we had in UKSM 1.0 in the historical. Parallel to UKSM 1.1 development, there was work going on to bring interactive ice sheets, both for Antarctica and Greenland, into our model configuration. And we built that work, and that was documented in Robin Smith's paper and Antti Sihan's paper in 2021 and 2022. So we brought that work into UKSM 1.1, and that became what was known as UKSM 1.2. And that model configuration we've been using a lot in a project called Terra Firma that I coordinate and making a lot of simulations that are contributing into an international TIPMIP activity. So UKSM 1.2 gets further developed into UKSM 1.3 by turning on the capabilities to run in emission mode, both for carbon dioxide and for methane. And so really it's the step to include methane emissions as well as CO2 emissions that takes us from 1.2 to 1.3. So in summary, then 1.3 is running in emission mode for CO2 and methane with interactive Antarctic and Greenland ice sheets, all based on UKSM 1.1. And the caveat there, I've written at the bottom, that implies that we're still using the same physical core as we used for CMIP6, which is HADGEM 3 GC 3.1. So please bear that in mind. Next slide, please. So to summarize pictorially and in words, you'll have seen this for UKSM 1. It is largely unchanged then for 1.3. We have the physical atmosphere as represented by the unified model as part of HADGEM 3 GC 3.1. We have interactively coupled into there the UKCA GLOMAP chemistry and aerosol scheme. In the ocean on the right, we're running NEMO 3.6 still in this configuration. For the physical ocean, SICE is the sea ice component, and then on top of that, we have the Medusa marine biogeochemistry interactively coupled in. The ocean is coupled through OASIS 3 MCT as previously, And then on the left, we have the land surface, where joules is part of the unified model, essentially, the land physics, and then we build in the biogeochemistry and the dynamic vegetation to take joules to become joules ES, as it's known for Earth system. So we have a full carbon cycle, and now, of course, we have a full methane cycle as well. So just to reiterate, and sorry, and I missed out the most important bit, we also have Greenland and Antarctica there, represented by unicycles, which is coupled both to the ocean and to the land and to the atmosphere. So in summary, UKSM 1.1 with interactive Antarctic and Greenland ice sheets run in emission mode for both CO2 and methane will be the UKSM 1.3 contribution to the fast track. The resolution will stay what it was for CMIP6, so N96, that's about 135 kilometers in the atmosphere, 85 levels up to the lower mesosphere, 1 degree in the ocean, and 75 vertical levels. Next slide, please. Okay, so what are we going to run? So we will definitely be running the deck. The deck consists of, so where it says ESM, that indicates that you're running in emission mode in CMIP speak. So ESM PI control means an emission-driven PI control. So carbon is free to evolve in the atmosphere. We're not prescribing the atmospheric CO2 concentration. But then we run a couple of actual concentration mode runs, the abrupt 4 times CO2 and the 1% CO2 to get the climate sensitivity and the transient climate response. At the bottom, there's a few runs that was in CMIP6 were part of RFMIP, I believe, that will delineate the radiative forcing characteristics of the model. And then the one in the middle, ESM historical. So at the moment, we're planning to run 4 members of the historical, running from 1850 through to the end of 2021. We may expand that, but 4 is what we believe we can manage at the moment. Next slide, please. And then we go into the assessment fast track, which Helene has mentioned already. I've put a bit of color coding here. The color coding is our best estimate of the moment, where green means we have a definite plan to run these and to run them in some kind of centralized sense, meaning a team will be tasked and coordinated to realize these. So on top of the deck, that would mean the scenarios, the 6 scenarios listed on the left there. And we would aim to extend the 4 historicals through to all 6 scenarios. So there would be 4 members for each 6. C4MIP, the carbon cycle one for characterizing aspects of the carbon cycle, seems particularly important because everyone's running in emission mode this time. And there's things there that will allow us to characterize the TCRE in particular. And then RFMIP to look at the transient forcing through the historical period, we're prioritizing as well. Then there is a loop round AirChem MIP that is in orange full line, and that's getting the characteristic probably at the moment. It may well not be done by the central UKSM team, but it will be done, I think, by, I hope, an AirChem MIP team with the UKSM team, so that and it may be that we don't do all of AirChem MIP, but we do the priority ones. So AirChem MIP, we're fairly confident we would do. And the GeoMIP experiment, which is building to some extent off the scenario MIP activities, we're also fairly confident we'll do in collaboration, particularly with people at the University of Exeter. And then you will see some ones that are yellow and dashed, and they're getting possibly as opposed to probably, because we believe there's interest in the community to do those. We're keen that they are done, but at the moment it's not clear who will do those. So those remain open questions where we would like them to be done, but we're not certain. And then the red ones, we believe we are almost certain, not absolutely, but we're fairly confident they won't be done with the Earth system model, and that's because they will be done with aspects of the physical model that are coming in a minute. Next slide, please. Just to mention UKSM2, so we are, and we have been for about the last 18 months, developing UKSM2. The fast track, unfortunately, came too rapidly for UKSM2 involvement in it. We weren't confident we'd have it ready in time. But as I say at the bottom, we're really encouraging groups in the UK that are running science MIPs to consider using UKSM2. UKSM2 will be available about the spring of 2026. It will use the new physical core model that Alejandro is going to talk about straight after me, GC5. It will run in CO2 and methane emission mode. It will have the interactive ice sheets, And then it has a
1
number
minute,
of
Colin.
other. Yeah, I'm done. This is my last slide.
Yeah.
It has a number of other developments that you can see there. So we're keen that groups, if you're running the science MIPs, consider using UKSM2. And we will, as the UKSM team running the fast track, commit to run the deck again the summer of 2026 with this new model. So there will be an underpinning data set available. We're keeping it the same resolution, N96 L85, 1 degree L75. We will have a hybrid higher resolution model developed, but that will not be for another year after spring of 2026. Okay, and I'm done. Thanks.
Perfect. Thanks so much, Colin. You had 10 seconds to spare in the end. Brilliant. Great. Okay, so like I said, we'll take questions at the end. I don't think there are any yet, so feel free to load up the Q&A. And now we'll move on to the what we call physical climate model. So over to Alejandro.
Okay, thank you very much. Good morning, everyone. So I'm Alejandro Bodas. I work at the Met Office, and I've been leading a project to develop a GC5 Central. So next slide, please. So in this slide, I'm summarizing what is GC5 Central. So GC 5.0 was developed following the standard GC bottom-up development process, and it was delivered a couple of years ago. And GC5 Central is basically a physical model based on GC 5.0, but has been kind of developed driven by user requirements from ECM, ESM, decadal prediction, and climate projections user requirements. And it's basically a GC5 configuration with the aim was to get the GC5 configuration with an effective climate sensitivity within the IPCC AR6 very likely range and an improved historical performance. This was done using open inform by atmosphere only perturb parameter ensemble based on the atmospheric model in GC5, and it's been evaluated across a wide range of areas. I will talk about the trade-off between basically degradation in root mean square errors and improving basically historical performance. And I have to highlight that GC5 Central is a provisional name. This name won't be used for the CMIP7, but at the moment is the project name that we've been using. And this the figure in this slide kind of summarizes the drivers and the outcomes. So it shows 4 lines, which are global mean near surface temperature anomalies. The black line is the observation. The green line is the GC 3.1 model, the CMIP6 model. GC 5.0 is in blue, and GC5 Central is in red. And the legend shows on the right the sensitivities. The ECS from GC 3.1 is 5.6, 6.6 for a GC 5.0, well outside the very likely range in AR7, and GC5 Central is under 4, so we are within that range. And as you can see in that plot, both GC 3.1 and GC5 kind of tend to warm very rapidly on the end, and the slopes that are in the middle of the legend show the differences in this trend over the last kind of 30 years of the historical record in those simulations. And GC5 Central reduces this closer to the observations, although it's still larger than HAT 5. Next slide, please. This is an additional example of improved historical simulation. This shows the basically northern hemisphere minus southern hemisphere anomalies in near surface temperature. So the top is GC 3.1, which shows a kind of a very cold anomaly in this metric with respect to HAT in FA in green, and then both GC 5.0 and GC5 Central improve substantially on this. All the GC5 Central is even a slight improvement over GC 5.0 on these metrics. So next slide, please. Okay, so this is our planned contribution to the CMIP7 deck. The resolution that we'll be using is N96 Orca1. So this is the LL resolution. The experiments, basically the same experiments that Colin has mentioned before, but all in concentration mode. So AMIP, PA control, 1% CO2, about 4 times CO2, and historical ensemble. And then the 3 experiments that are coming from the radiative forcing MIP. to characterize the ERF during the historical. And the timeline that we're planning to get these runs done is basically by March 2026, so throughout the next year, and probably even if we can a little bit earlier. And we are now working towards documenting this model in 2 different papers. One which is basically mainly documenting the configuration, and a second paper on the specific of the methodology. Next slide, please. So these are the basically the expression of interest from Community MIPs to contribute with this model to the assessment fast track. So we have mainly three Community MIPs: RF MIP, CF MIP, and the DA MIP. And there is also potential work in development of a N216 or K-quarter resolution from this configuration that may contribute to the decadal prediction MIP, but that's perhaps on a slightly longer time scales. That configuration is still under development. Next slide, please. Right, so I'm going to spend the last 3 or 4 minutes talking about the methodology that we've used to develop this configuration and some of the trade-offs. So the methodology is based on a published method by Beate et al. In 2022, but we're using a different basket of metrics and constraints. The methodology is basically applies to the first 2 steps that I'm listing there. So we run a PP based on with atmosphere-only simulations, AMIP and AMIP plus 4K, to characterize both the present-day performance and the feedbacks. And then there was develop emulation, and with an optimization process, we selected alternatives within the kind of the lower range of the feedback parameter, and hence climate sensitivity. Then we coupled those variants, and many of them drifted too much. So there was a step where we had to screen these short couple spin-ups, and we ended up with a reduced ensemble of variants. And some of them were rejected again based on other metrics, so we ended up with just a few. And the bottom left picture is basically the evolution of the tuning of one of these, which is the one that ended up being selected as the final configuration, from the left, which is the outcome of the optimization project process, to the right, which is the model that which is closer to the energy balance, which is the one that we selected in the end. And the right-hand side figure basically shows how we use perturb parameter information to inform this tuning. So it basically shows the emulated predictions of 2 variables: nature wave, which kind of is related to the TOA imbalance in the y-axis, and the net feedback in the x-axis, which is related to sensitivity. And the dot is GC 5.0, this black dot, and then we show basically the emulated sensitivities to parameter changes in these color lines, and the boxes show basically where the parameter, basically in which part of the range that was changed we ended up for this particular variant. The blue box is the emulated prediction for all the parameters combined, and the blue dot is the kind of define the actual value. And you can see that the emulation was quite good in this case, but it also shows that there was basically a trade-off between, or a combination of, pushing the sensitivity towards lower feedback parameters, but also trying to constrain the net TOA at the same time. So there is a combination of effects from different parameters. Next slide, please. So I'm going to finish my presentation with basically trying to put TC5 Central in the context of CMIP6 and explaining the trade-off that we had to make. In this plot, I'm showing basically root mean square errors. Each line is a single historical simulation, and there are 3 blocks which are repeated, the same variables. So there are one line in each of these blocks is a single model. So the blue line, and they are normalized to the GC 3.1 MM model. So that's the one with ones everywhere. So GC 3.1 was performing very good, as well as a GC 5.0 in green. And basically, as you can see, the trade-off is basically that GC5 Central is performing with larger root mean square errors in these metrics. So that's the main kind of trade-off, but still well within the CMIP6 ensemble. So that's basically it. I'd like to also take the opportunity to thank everyone that has contributed to this project, which has been both people in the Met Office and also from the academic community. And I'll leave it there. Thank you very much.
Great. Thank you, Alejandro. Really nice overview of everything we've got going on there. So without further ado, we can move now to the next talk. So Malcolm Roberts is going to describe how we're also pushing boundaries of high resolution. Malcolm.
Thank you very much, Chris. Thank you. Yeah, good morning, everyone. Yes, pushing the boundaries, pushing data, pushing everything. So thank you to my group and many other people who've helped to set up this model as within our European ERI project, which I'll say a bit about in a minute, as well as colleagues at Reading and elsewhere. Next slide, please. So the high resolution model, so the proposed configuration of this is based on a model that we've been running as part of our EU ERI project using CMIP6 forcings. So it's based on GC5, so similar to Alejandro, the baseline is GC5, but we've made some modifications of the model. So we've used the COMORPH A9 atmosphere convection scheme and done some kind of various tunings for TOA and other things to make the model in balance. So it's GL9, NEMO 4.0.4, and SI cubed as the model components. It's concentration driven. So again, it's like Alejandro has just described. So we've been running that for kind of standard CMIP6 forcing. We've done a spin up. We've done 200 years of PI control, and currently the high resolution model is getting through nearly through the historical simulation. It's racing the current supercomputers in terms of finishing. And so we have a reasonable idea of what that model is going to look like with CMIP7, assuming the forcings are fairly similar. So we're going to use the end of the 200-year PI control as our initial state to then start the CMIP7 simulations. There is an issue here that we think some of the CMIP7 forcings might be somewhat different to CMIP6, particularly the solar and the volcanic. So we're going to do some testing, hopefully in the next month or two, to see how different they are and whether we will need to extend the current kind of PI control that we're starting from a bit before we can initialize the other simulations. The plan is to initialize both a 500-year PI control and a 3-member ensemble of historical and future from that point. Because if you look at the bottom here, so on the old supercomputer, this model was going at about 0.7 years a day. On the new computer with a lot more processors, it will go at more than a year a day, but only just. So we want to run 4 of those in parallel. And there's not that many more than 500 days between now and the end of 2026. So if you do the math, we need to start fairly soon, and it's going to be tight to get those simulations finished. But that's the idea. We will also likely run a parallel low resolution counterpart because this model is different from the other 2 models just described. So to have a reference point at least might be useful. And then I'd say that we will need to run on Gen 1B supercomputer here at the Met Office because we're going to run 4 of these in parallel. In terms of the simulations, so HH, perhaps I should have said, the resolution here is about 20 kilometers in the atmosphere and 8 kilometers in the ocean. So it's N640 Orca 12 resolution. So the plan is to run 500 years PI control, 3 members of the historical, 3 members of the future, possibly with 2 scenarios yet to be decided, and then several of the other simulations that have been described before. And then, so as I say, on the new machine, we at least know that we can run at a bit more than a year a day. So depending on how many nodes we can get, we do have that capability. Next slide, please. So in terms of biases, so if we look at the PI control simulation from the 3 resolutions that I've ran as part of ERI, again with CMIP6 forcings, the kind of take-home message is that the high-resolution model does a very nice job at the low and mid latitudes, but gets a bit warm at high latitudes. Particularly the Southern Ocean sea ice is a big issue because we have a permanent polynya in the Weddell Sea, and so the sea ice is bad in the Southern Ocean. It's also not great in the Arctic, but we either run this model or we don't run a high resolution contribution because there is no time to start. We think we probably now have some ideas of how to solve some of those issues, but it's too late to do that. You can see on the left here, this is just, again, similar to Alejandro, a trace of the surface air temperature in the historical with the 3 different resolution models. And you can see the green is kind of mapping the lower resolutions and the observations pretty well, getting to this jump that we see in Alejandro's plot as well around year 2000. So we'll see how the high resolution model does there. Next slide, please. This is yet another version of looking at a bunch of variables and a bunch of biases. So here, again, the low resolution and the high resolution. On the y-axis, there's a few different variables, and on the x-axis are different regions of the globe. Dark green means the model is doing very well compared to the CMIP6 ensemble, and dark red means it's doing very badly. And so I think overall you can see that HH does a pretty good job of the mean climate. You can probably see in the Arctic and Antarctic, which are the kind of left and right sides, that there are certainly issues with some aspects of the model there. But as I say, the sea ice we know is poor there as well. But I think overall it's doing a pretty nice job in terms of mean state. Next slide, please. And then, so, well, why, if it's not a perfect model, why would we do this? It's going to be very expensive. It's going to take a lot of time. It's going to take a lot of processing of the data to publish. Well, I think this model, we can do things with this model that we can't do even with a large ensemble of lower resolution models. So we can look at coupling. So fundamentally, the air-sea coupling is different at high resolution than low resolution. So actually looking at those interactions between atmosphere and ocean is going to be different. We can actually look at ocean eddies, which obviously we can't look at low resolution. So we can look at how those evolve, how those change, how those ventilate the deep ocean, how they change heat uptake. AMOC, so we have a model that can do a reasonable job of the heat transport due to AMOC. So yes, the volume transport is perhaps a bit high, but the heat transport here in the pre-industrial is about 1.3 petawatts, so pretty much in agreement with observations. In terms of extremes, the tropical cyclones are pretty good, certainly in terms of their distribution and their variability. At 20 kilometers, you can't expect the wind speeds to be as observed. But we can definitely have interesting looks at variability and how tropical cyclones and other extremes might change in the future. We're currently doing some work on the marine heat waves in the simulations we have. And again, the high resolution model looks like it's doing a very nice job of the marine heat wave distribution compared to observations, compared to the lower resolution models. And then in terms of impacts on uncertainty, so there's work coming out of our previous Primavera project, which showed that with the high resolution model, with the Gulf Stream that actually separates from the coast differently from low resolutions, let's say, it's again not perfect, that we found for at least for one ensemble member, the precipitation over Europe was effectively outside of the CMIP6 and the UKCP ensemble, because in the future, the Gulf Stream moved north as the AMOC declined, and that had a teleconnection, probably involving variability as well with precip over Europe. Now, low resolution models, so that all of the CMIP models, the Gulf Stream separates far too far north, so it basically hugs the coastline before separating. So you cannot get this this interaction because the Gulf Stream cannot move northwards. And then probably as you're aware, so some of the work with the CSM group in the US with their 10-member ensemble from 1920, suggesting that some of those high resolution models can capture these historical trends, both in the Southern Ocean and in the Eastern Tropical Pacific. we don't quite know yet what it is about resolution that allows you to capture some of those things, but clearly there is something there that we're learning from. Next slide, please. And then just finishing up, Chris, yes. So we're going to be challenging Matthew's team with data. The data is going to be huge. So how we process that and publish it is going to be interesting. As I said, the timescales are extremely tight. And depending on how the forcings are different, that will be another challenge. And I'd say that that's certainly not a perfect model, but I think we can learn new and interesting things from it. Okay, thanks.
Brilliant, thanks, Malcolm. Yeah, really nice overview. Yeah, so that wraps up our whistle-stop tour of the 3 model configurations we're planning to use. As I said, we'll take questions at the end. I know there's a couple come in already. So probably what we'll do is I will simply read out the question unless there's a real requirement for somebody to ask it in person. Alejandro and Malcolm might want to look at the questions already because I think they're directed at you. But the next couple of talks, we're going to move on to the how. Particularly, we're going to look at the data delivery and the UK's contribution to the ESGF archive. So first, we've got Matt and Jared talking about the data delivery.
Good morning, everybody. Yes, so I'm going to talk about the data delivery with a few bits on documentation from Jared in my team. Next slide, please. So a quick outline. I'll go through some of the changes we're expecting on the technical side for CMIP7. Then look at the data delivery process and the CVDS system and some of the changes since CMIP6 in particular, and finish up with some of the GitHub activities which we need to just start now in support of this. Next slide. So the first of the expected changes for CMIP7, this is something everyone who deals with the data will need to be aware of. I'm expecting more communications to come out about this. Branded variables, a new concept, will replace the MIP table and the variable name in the file names. So the way you identify and search for data will change. This change introduces a lot more information into the file names and the facets with which you can search for data on ESGF. So for example, TAS AMON, surface temperature monthly means, you'd be familiar with from past CMIPs, will be changing to something with the file name there, where we've got details on how the file is, the data is processed. Does it time mean? What's its vertical shape, horizontal shape? Is there any masking? What frequency is it? And what region does this cover? So this will give you a bit more information when searching for data, possibly clearer than having many different MIP tables with names which don't necessarily correspond to exactly what you might expect. Next slide, please. Alongside this, the data request, defining all the variables and working out which variables are wanted for which experiments, has been re-architected and simplified, and a very large task team has been working on that. Many of you may have been involved in the task teams looking at the different themes within the data request and defining variables. So thank you for that. Again, the data request is expected to extend beyond the assessment fast track in support of community MIP activity. So this will be something we're working with for some time. I'm expecting to deal with changes as they arise. Experiment definitions will be placed within the controlled vocabularies, a set of JSON files which define all the central information about the technical facets of our data for CMIP7, and these will also be extendable as new MIPs come along to find new experiments. Model descriptions, so ESDoc model descriptions, we had last time a sizable exercise putting that together. This has been dramatically simplified thanks to the model documentation task team within CMIP, and will be required for registration of models. So we need to get this sorted ahead of time, but it should only be around about an hour or so's work per model, vastly simplified compared to what I had before. Next slide, please. Briefly covering some of the changes on ESGF, because I know Shard will pick this up next. So ESGF is being re-architected with a new system expected to be deployed in July. The data indexes for CMIP6, CMIP6 Plus, inputs MIPs and ops MIPs will be migrated, but not CMIP5, at least not initially. So the CMIP5 archive will disappear from ESGF, but the data will still be around. So CEDA has quite a lot of this in their archive. Other projects will also be expected to migrate over to the new ESGF system in the longer term, for example, Cordex and others. Next slide, please. Okay, changes to our data delivery processing. CGDS. So those you involved last time will be a fairly manual process was used. So to run each of these stages ourselves. This is now simplified down to a single Silk 8 workflow. All the settings for this will go into one control file, the request file, plus a list of variables that you want to produce, which we can extract from the data request. This will continue to evolve according to some of the requirements for CMIP7, but we'll have a Python plugin system to support other projects and different sets of mappings, which will be coming in our next release. So other projects should be able to define their own mappings, and users want to use it for ad hoc work will have the capability to do that. The development has predominantly been within the Met Office, with deployment to Jasmine not as frequent. We need to work out how to support the wider UK community, given our limited resources. So possibly setting up a team of MIP or project representatives to introduce to how CDS work and can be used. And on top of that, add in some drop-in sessions. Next slide, please. Some of the changes that are coming up. So first priority, we need to get the mappings up to date for CMIP7 as the variable definitions change and adapt to branded variables, add in support for iSheet data in UKSM 1.3, and try and implement some lossy compression to try and reduce the amount of data we are producing. Initial explorations into this has started using some of the libraries provided by CEDA. We then to make sure we are in position to deliver the fast track data and adapt to the new mass coming as part of the supercomputer project. We hope to get to regridding of data and improved processing alongside model workflows where we don't sort of rely on mass for the archiving, but that will have to come as a later priority. Next slide, I think over to Jared.
Yeah, so just a quick note on the documentation for CGDS. So going forward, there's only one place you need to go for anything regarding documentation, and that is on our relatively new MKDocs material-based site, which is hosted on GitHub Pages. The link for this is in the bottom of the slide. And this has essentially combined some of the fragmented documentation we did have previously. So if you're using CGS back in for CMIP6, we had the old Sphinx docs and some pages on the track wiki, and we from going to the SRS to GitHub, we ended up using some different tools such as the GitHub wiki and Confluence. But now if you need to find anything at all, it is now all on this one page. And with the GitHub repository going public, we also do not have to support any mirrors. So there's no separate mirror for SRS or on Jasmine. Everyone should be able to access this page. Next slide, please. Obviously, there's not enough time to do a demonstration of CGS, but we are recently adding a quick start guide, which will be a nice easy entry point for anyone who wants to kind of get hands-on with CGS, just to kind of run through it and see what's involved with actually running the conversion workflow. This quick start guide will provide you with an example request file just for producing a few years of A1TAS, and needs very minimal modification. As Matt said, a lot of the previously manual steps required to do the processing are now all within the workflow. Next slide, please. So this basically reduces down to, once the request is configured, you need to just run a few commands for preparation in terms of creating directories and internal representation of the variables list, and then you can run the CGS convert command, which will automatically create a Silk 8 workflow for you and run it. And that will do all the extraction of data from mass, validating that data, performing the actual summarization using MIP-convert, concatenating the resultant files, running quality control, and then placing the data back into mass. This is slightly different on Jasmine, as I don't think there's a mass partition yet, but there you can still run that step manually, and this is all covered in the quick start guide. Thank you.
Next slide, please. Okay, last slide from me. Some of the activities that are going on around CDS and data delivery, a number of them are going on the new UK NCSP GitHub organisation. So CDS development and the documentation will remain within the Met Office CDS GitHub repository. Support for UK CMIP7 will be via a CDS support GitHub repository under UK NCSP. Queries on how to do things in discussions, help for specific problems in issues. We aren't actively monitoring this yet. We'll work out some support processes to make sure we keep a close eye on this, and more communication will come when we've got that done. Something I've alluded to earlier is getting an idea of how we produce different variables, so the mappings. We've started to put together a process for collecting and recording this. This is the equivalent of the Google spreadsheet we had in CMIP6, which many of you may remember, and hopefully not have too much post-traumatic stress from. Communications around this are in preparation. Other things which we'll be recording here are things like metadata definitions, similar to the Rose Suite info files you would have had last time, but separate, given that the Rose Suite configuration will be changing as it moves to Git. And then simulation processing will also occur under this organization too. That's all from me. Back to you, Chris.
Brilliant. Thanks, Matt and Jared. Great stuff. Yeah, do keep an eye on the chat. I think there's one in there for you that we'll come to. But we'll go straight on to the next talk. So Charlotte is going to tell us now about the CEDA plans for CMIP7. Over to you, Charlotte.
Great, thank you. Next slide, please. Okay, so CEDA is going to be the home for data that's produced by the UK CMIP7 modelling community. And we're going to be replicating the CMIP7 deck and fast track via our ESGF service. We're also currently replicating the CMIP7 input for MIPS, so that's the forcings data that's used to force the simulations for CMIP7, and also a home for the OBS for MIPS data. And as Matt Myslinski just mentioned, lossy compression may also be required. Next slide, please. So CEDA is also supporting the REF, that's the Rapid Evaluation Framework. That's creating a set of metrics to assess some of the behavior of climate model simulations for CMIP7. They are beta testing that through May, and they're making use of Jasmine facilities. So later, the CEDA will be hosting some of those Python applications that will give us some near real-time analysis of the data for CMIP7 that's uploaded to ESGF. And as part of that, to note that really only well-formed data that passes the required quality control checks are going to be able to benefit from inclusion in the REF, because they'll need to be fit for being able to be ingested into those Python applications. Next slide, please. So a big part of what CEDA is doing for for CMIP7 is running an ESGF next generation node. So just as a little bit about the architecture of that, there's going to be two index nodes, one in the United States, the Western node, and the Eastern node based at CEDA. So both the East and West nodes will be publishing data. There'll be a centralized event stream, and from that, both the East and West will have their own mechanisms for the discovery of data based on the particular experience and access interfaces that we are running, either at Oak Ridge in the United States or at CEDA. Can I have a next slide, please? So this is a rather complicated slide, but this is the ESGF pipeline. I'm going to pull you over to the right-hand side first, where there's the box about the user and the client. So that's about how you discover data and get data and subset data, or various user access protocols that are based on our spatial temporal asset catalog that are running at CEDAR, and also is being run the other index node in the States. But for an ESGF node, that's the... Okay, I'm going to pull you over to the left-hand side now and say there's modeling centers. You're responsible for the configuration of your models, the running of your models, the CMORization of your model output, and quality control. When that data comes to an ESGF node, there will be some further quality control, and we'll be trying to be more strict about that, because what we've found is that the analysis of data is much more effective when it's well formed, and with so much of it, that's an important part for us. But well-formed data will be able to have the metrics run from the ref, and those model outputs will be accessed via various methods. At this stage, I'm going to pause on this slide and move to the next one. So next slide, please. Okay, so this is about storage. We've got confirmation of some new funding from NERC, which CEDAR is going to be using to procure additional disk capacity for CMIP7. It doesn't cover us for the whole of what we expect to need to deliver for CMIP7, so there is some data from previous CMIP cycles that we're going to be moving to tape to ensure that we've got capacity. But with a realization that there are some CMIP6 data sets that are going to be required for comparison to CMIP7 in some of the Working Group 1 report work, but also that CMIP6 data is generally relied upon for the Working Group 2 and Working Group 3 IPCC reports, who have a tendency to use the data from the previous CMIP cycle. So it's going to be important for us to keep some of that data accessible as possible. As I mentioned before, we're expecting lossy compression as a general rule on data that's area mean, so like zonal mean data, or that's time averaged fields. But there's some ongoing work at CEDAR into some more nuanced approaches to lossy compression. Next slide, please. So this is something about CEDAR iCompress, which is a piece of code that's been developed by Neil Massey at CEDAR. And so what this does is to look at what is the information content of data, and to lossily lose the information that is effectively noise. Now, this has to be, if were this to be applied, it would need to be done in a very careful way. There are some fields for which continuity is required, specifically those that are derivative fields. But nevertheless, there's really quite significant savings that can be made by the careful application of compression. Next slide. So this is the final timelines. There's a typo here, but we'll get to that. So May 2025, we're supporting the ref beta testing. And I noticed that Brian's made a comment, but I'll come back to that. From July, is our deadline for being ready at CEDAR to begin receiving CMIP7 data, with the ref frameworks operational from October, and January 2027 is when we expect the fast track data to have mostly arrived. And I was asked to be short, and so that's the end of my presentation.
That's great. Thank you, Charlotte. Yeah, really useful to see that overview. So we are drawing near the end. Thank you so much to all the speakers for keeping to time. We're bang on time. We're just going to finish with a couple of minutes on wider engagement and next steps that I think Jane's going to present, and then we'll come to the questions.
Great, thanks, Chris. Good morning, everybody. Next slide, please, Wendy. I'm just going to just briefly, I just have a couple of slides on a little bit more around project engagement and some useful information for people within the community in terms of engaging, particularly if you're involved in MIPs, potentially planning to run simulations. And want to see what kind of infrastructure and setups we're going to be working with this time. For those of you who are involved in CMIP6, you'll be aware that a lot of the project management side of things and the documentation of simulations was all done on the Met Office Science Repository Service track system. We're not going to do it that way this time. We're all hosting it through the UK NCSP GitHub repository that Matt already mentioned. So this is a little bit of a work in progress. We're setting up the CMIP side of this at the moment, so bear with us while we try and get that sorted. But essentially, this will be a public open access GitHub repository, and here is where we're going to essentially document our processing of the forcing data and also the simulations. So running of the simulations, what simulations we've run, and all of that. So very similar to the track system that we had for CMIP6, but moved over to GitHub in this instance. Next slide, please. I should say as we've alluded to throughout the webinar today, in the first instance, we very much focused on the assessment fast track, but it should, the GitHub page will be open if you are involved in MIPS to essentially pick up and use that infrastructure. So thinking of the MIPS again and the longer term science MIPS, from our own kind of UK CMIP modelling project perspective, at the moment we are obviously very clearly focused on delivering on the fast track, but obviously there's clear linkages to the longer term science MIPS. And so we'd like to ensure that you kind of get that information if you're involved in a MIP. We're trying to see how best to ensure that transfer of information from the project team down to the MIP leads. So we'd like to collate a more up-to-date list of MIP leads within the UK. So if you are leading a science MIP within CMIP7, within the UK and are planning to maybe use one of the UK models, please use the QR code on this slide to basically sign up. So if you're happy for us to get in touch with you, and if you're happy maybe to be part of a MIP Leads working group. So this is our kind of idea at the moment, is that we'll have a working group to center around the MIP Leads. So essentially we can just ensure that you get the kind of most up-to-date information. It shouldn't be an over-owners working group, meeting occasionally and just staying up to date. So please use that QR code. We have also, in terms of other activities, we did propose a NERC open call to support the longer term science community MIPS. This is currently sitting with NERC. We've had no decision around that. So if this is something that you would be very keen and would need, we suggest that within your own institutes that you essentially really do push for this open call. At the moment, there's been no decision on this from NERC. As part of that, and through the UK NCSP, we have an aspiration, obviously, to host maybe an in-person UK workshop. Obviously, we'll be quite busy to the second half of this year, producing the simulations and documenting those. So it might be ambitious to have it this year, but certainly late 2025, early 2026, that's an aspiration. So when data becomes available, and then to have an in-person workshop to encompass both, running simulations, but also the kind of the data analysis side of things. So ear to the ground on that. We will advertise that if and when that happens. That will be obviously subject to funding as availability as well. So I think that's really it from me on the project engagement side. So hopefully there's just a couple of little things there that will be of use to people. Back to you, Chris.
That's fantastic. Thanks, Jane. So we have run bang on time so far, which is a really good, augurs well for the delivery of CMIP7. I hope the rest of the project goes just as smoothly as the webinar. We're going to move to the Q&A. So we've got, I think I can see about 4 questions in there, and I'll go through them in the order they were asked. To keep it short, I'll ask them, but if the asker of the question wants to add anything, we can come back to you. So firstly, from Thomas Aubrey asking about CMIP6 versus CMIP7 forcing. So particularly to Alejandro, whether you used that in the GC5 tuning, but I think Malcolm will come in on that as well, actually. But Alejandro, do you want to answer?
Well, the answer is no, we haven't used that because this project has been running for quite some time, well before those forcings are available. So we've done all the development with CMIP6 forcings, and we are ready to test the impact of CMIP7 forcings as soon as we can. Yes, because that's a bit of a worry if there's a big change in them. Yeah.
Cool. Thanks. Yeah, I think it's fair to say we are aware the volcanic in particular is different, but yeah, not yet fully quantified. Malcolm, did you want to say something?
Yeah, no, same answer from me. So obviously we've only had CMIP6 forcings till now, so that's what I've used. But we are very keen, given that we want to start from the existing PI controls. We, as you know, in the next month or so, once we have the CMIP7, particularly those forcings that have changed, to test whether it changes the climatology of the PI control. And if it does, then we'll have to extend our PI control a bit before we start the historical.
Yeah. Okay. Thanks, Malcolm. So yeah, watch this space. Hopefully that makes sense, Thomas. But feel free to get in touch if there's anything you think we need to know beyond that. Okay. James then asked about the high resolution runs. Do they have chemistry and aerosol? Malcolm?
So they have GlowMap interactive aerosol, prognostic aerosol, but no chemistry. The physical models, as you would expect, and already very expensive. But yeah, they have the proper aerosol.
Great, thank you. Fiona had a question for Matt and Jared around CDDS and whether it's still possible to run CMIP6-like data requests.
Yes, so we'll maintain the capability to do that for some time until we're well bedded in with CMIP7 ways of doing things. But yes, for the foreseeable future, I still expect to be able to process CMIP6-like or even Cordex-like models.
Great, thank you. Gareth has got a couple on here as well. So an overall summary of what model is planning to run, which experiment, will that be published? Yes, this webinar is explicitly intended to help answer that question. So we'll be publishing, obviously, the recording and the slides from here. But yeah, we will keep that updated. And again, if you wanted to sign up as a MIP lead or towards the MIP working group, or somebody in your MIP wanted to do that, then we can definitely do that. I've just seen the next one from Gareth as well. Would it be possible to have normal links as well as QR? Yes, we will provide those as well. Those were just kind of nice, easily visual ones that you can do while the presentation whizzes through, but we will certainly make all the links from today available. We might have time to put some of them in the chat actually, but I suspect not, but we'll certainly do so afterwards. Thanks, Gareth. Okay, from Lauren, what resources and support are available for the community to run and process data for Fast Track and Community MIPs? So I might open this to others in a second. I think the intention is that we will more centrally run and process the Fast Track ourselves. So everything you've seen today around the Fast Track hopefully will come from the teams you've seen presenting. Beyond that, although that won't necessarily cover all of the experiments. So if there are experiments missing with any particular configuration, then please get in touch and we can discuss that. And beyond the fast track for the community MIPs, yes, we will be looking to maybe run different configurations. So as Colin described, UKSM2 will become available, and that will be hopefully ported and available for community use. The support directly to do things like data processing is limited. So again, the goal will be to help people run systems like CDDS themselves rather than to have the data processed for you. But we would hope to be able to provide support for people to get up and running. I can see Matt giving a thumbs up. Did you want to say anything beyond that, Matt?
No, you covered it well. Thank you, Chris.
Great. Okay. And I don't know if any of the model configuration people wanted to chip in, Colin in particular, in terms of ESM as a community model, perhaps. Apologies to put you on the spot. Maybe not.
Colin is trying to reply, but maybe he's not muted. And while he's setting up his technical headset.
Sorry, I've got a new headset. There was a button that I accidentally pressed.
Okay, we can hear you now.
So UKSM2, yes, we will endeavour to make that model run on whatever the NERC machine is at the time. Of course, I'm not sure we know what the NERC machine will be at summer of 2026, and provide with NCAS CMS support for people to get started with that model and use that model, yes. So that definitely is our preferred option for the science MIPs, that people go to UKSM2. We think it's a better model, and it's the one that's future looking. So that's why we choose that one and try and port that one particularly.
Right, thank you. Yeah, so Lauren, thanks for that question. It's important. As you will have picked up, the timeline for the fast track is sufficiently challenging that's taking up most of our attention at the moment. But yeah, we're not blind to the need for planning beyond it. And that, as Jane said, this is the first step really of our engagement with the wider community, and we hope to have community activities like a possible workshop coming up. So please do keep in touch with us. I hope that's sufficient answer for now, but if you wanted to chip in and ask any further clarification, please do. Okay, just a note from Helene in the comment as well that fast track data will be available through the REF activity as well, which is a nice new initiative. Okay, new questions coming in. Gareth, again, good to hear a question about volcanic forcing. Yes, I mean that's just a comment, Gareth. Yes, we're aware that new forcings will affect potentially both the pre-industrial state and the historical. And at CMIP6 that did cause some issues, so we're aware of the need to test those as soon as possible. I think most of them are more or less available. And maybe as a quick advert, there's a nice CMIP activity called Fresh Eyes, which is aiming to engage early career scientists and people who are new to CMIP, and there's a task team on there who are looking at forcing data sets as well, hopefully to try and get an early view of any issues that might come up. Okay, so that is all the questions that are currently typed in the Q&A. We've got 10 minutes, so feel free to add more, or as Jane has just said, if you want to raise a hand and ask an in-person question, please do so. Or if any of the speakers wanted to come in and give more detail on any of the answers. Okay.
Just while we're waiting, Chris, one point coming back to Lauren's question. So one thing that was done by CMIP in CMIP6 was that they ran a number of their simulations on monsoon. So there is the possibility, and again, you know, UKSM2 absolutely should be ported and available to run you know, seamlessly on monsoon with time. So there is the potential for, you know, potential MIP leads to apply for a project on monsoon. So just to be aware of that potential, particularly if they have, you know, I think they might need a Met Office co-PI on that. But that is a potential, and I think a potential resource that should be at least investigated by potential MIPs. So that would be down to the MIP lead involved to kind of spearhead that. But I know CMIP did have good success with running, you know, some simulations internally in the Met Office, but then a number of simulations spread out across monsoon, and that also facilitated kind of made, you know, CDDS, the data processing side of things, easier as well.
Great. Okay. So I'm not seeing any more questions or hands. I'm going to take that then as an opportunity to wrap this up, maybe a couple of minutes early.
Just one point,
Yes,
Chris. Sorry,
yeah.
Malcolm just made a comment to me there, actually, just to highlight activities around forcing data processing. So again, we haven't explicitly covered that today because there is quite a lot to cover just on the basic modeling capability. But again, just to be aware that within this, the CMIP7, UK CMIP7 modeling project, we have a working group around forcing data that's leading basically the processing of the CMIP7 data into the required ancillaries for the UK models, so the GC and UKSM models. So again, just to be aware that I'm leading that group. So if anyone's got any further questions on that, please do feel free to contact me. There's a wide group of people involved from both within and outside the Met Office.
Great, thanks, Jane. Yes. Okay, so let's wrap up. We've said we will publish the recording and the slides. I'm not 100% sure where we will publish that, so I don't know if someone from UK NCSP can clarify. Will that go on the NCSP website, or will they be emailed a link? I don't know, Wendy or Rose, can you answer that?
Hi, yes, will be emailed to all those who have registered in this event, and the NCSP website is still under building. But if once we got that, yeah, there will be a link for you all to access this recording. Thank you.
That's great. Thanks, Wendy. Sorry, I should have known that in advance. But yes, we will certainly be making all of this available. Jane and I are very happy to take questions offline as well. If anybody has anything they want to follow up on afterwards, please do get in touch. Otherwise, I think we can wrap up for today. Just want to say a big thank you again to everyone for joining us. Thanks to all the speakers. Thanks to Wendy and Rose for helping with all the logistics to put this together. And we look forward to making big success of the UK contribution to CMIP. Thanks, everyone.
Thanks, everybody. Goodbye.
Bye.
Bye.